Hi, good evening everyone. My name is Monica Mallela and I am one of the TA for this NPTEL course on basic construction materials, and this is the week 11 of the course. Week 11 pertains to wood and wood products. Like so far we have seen other materials such as cement, concrete, steel and other metals. Today in this session we are gonna discuss about wood and its products. And is wood a construction material? Like you would have seen some earlier constructions like which they used to make of made out of wood. Why the wood is considered as a construction material? Like in a way it is like the construction can be simple and easier. The construction can also be easier and it will be economical. And in some places, like till now the wood constructions will be preferred in some places where like in some hilly regions where the landslides will be more, or in regions such as Japan in which earthquakes will be more. In such a regions the most of the constructions will be made out of wood, because like if the construction is made out of wood, there will be the damage due to this natural occurrences, or the damages due to this natural occurrence disasters will be very less. And in economy wise also, the wood is considered as a best construction material. So and what where will you get this wood from? Like from trees which are grown, like for suppose it not from plants, from the trees which have large trunks. From those trunks we can make wood out of those trunks. Okay, so I have wait, okay, I have made some sample questions based on week 11 content. So by looking into those questions parallelly, we can also see the content related to this question, so that we can cover the complete content of week 11. Okay, like which of the following tree yields hardwood? Like as I said, wood will be obtained from the trees. The trunk part of the tree will be used for making of the wood. So based on the tree, the wood will be different. Like the wood will be differentiated into hardwood and softwood. So based on that, the trees will be classified. So which of the following tree yields hardwood? In this case, the answer for this is deodar. Because all this chir, sesame and pine, all this belongs to the category of softwood. So deodar belongs to the category of hardwood. So which of the following tree yields hardwood? That is deodar. So we'll just look into the classification which is shown in the lecture material. See, the outline of today's lecture will be based on this wood products, use or applications, and structure of wood, shrinkage and seasoning, mechanical properties, and preservation techniques, and what are all the byproducts from that. Okay. See, as I said, the wood is considered as the earliest construction materials used by mankind, and the advantages are easy to use and durable. For suppose if you consider a good wood which is in a good condition and which is well seasoned, then you can say that the wood will be durable for many years. Durable, high strength, depending on the while selecting the wood for the construction, you have to select it based on the direction of the growth of the grains. Based on that, you can say whether the wood will have higher strength or not. That in the subsequent discussions you will be able to understand. And the another advantage of the wood is low weight. It has low weight, and it is widely available, and it has low cost, and in aesthetics wise also it will look good. The wooden constructions will look good, and still very widely used today for different purposes, if not for the complete construction of the building, still we are widely using wood for different purposes, like building frames. Like for suppose in construction, formwork can be made out of wood. Formwork can be made out of wood. So building frames, bridges, like in some parts wooden bridges will be available. Utility poles, floors and roofs, piles, and railway sleepers. Railway sleepers can be either like concrete or timber, like wooden sleepers. See here, you can see the classification. Trees are divided into two broad classes. So depending on the tree, the wood is classified as whether it is hardwood or softwood. So in hardwood, the nature of the trees will be, those are tropical and broad leafed and deciduous. Deciduous means those the trees will shed the leaves annually. And porous. Porous means contain vessel element, like it will have some some kind of porous elements on the upper part of the wood. So the examples for the hardwood are teak, sal, and oak. And as I said earlier, deodar also will come under the classification of hardwood. And when comes to softwood, it is coniferous, have needle or scale like evergreen leaves. See, you can see in the images, like it would be needle or scale like evergreen leaves. Like they will not shed the leaves, they will be evergreen. Like leaves will not be shed at any weather condition. And those are non-porous. So examples are fir, pine, and cedar. These are the examples of softwood, and some of the wood species which are available in India are mentioned here, like teak, padak, rubberwood, sal, deodar, rosewood. These are all the different kinds of wood species which will be available in different parts of India. Okay, so the into the next question. See, the age of tree can be known by examining, like all these options mentioned here, like cambium layer, annual rings, medullary rays, and hardwood. Like these are all the components of the like the tree, like stem part of the tree. These are all the different components. Like in which of the particular component pertains to the age of the tree. So based on that, you can say what would be the age of the tree, whether it is 10 years or 15 years. What would be the age of the tree by examining one of the property. See, the answer for this is annular rings. So based on the pattern of this annular rings, age of the tree can be determined. The age of the tree can be determined by examining the annular rings that you can see in the lecture here. See, the structure of wood. When it comes to structure of wood, each annular ring of exogenous tree is composed of, like if it is early wood, light rings will be visible. If it is early wood, light rings will be visible. So rapid growth of hollow, thin-walled cells during spring or wet season. And late wood like dark rings will be visible. So dense growth of thin-walled cells that are much harder and stronger than the light rings during summer or dry seasons. You can see in the image here. See, if it is late wood, the rings are dark and those are dense. But in case of early wood, the rings are lighter and those are not dense. So based on the pattern of the annular rings, you can say you can determine the age of the tree. You can determine the age of the tree, and these are all the different components like structure of wood. The main structural features of the tree stem, like the stem of the tree will have different structural features. In those, the main structural features are the pith, hardwood, heartwood, sapwood, cambium, inner bark, and outer bark. Like these are the different layers. Pith is the center of the stem. Pith is nothing but the center of the stem. It is nothing but the, see here you can see in this image, pith is the central axis of the stem, and hardwood is darker, non-living, and provides structural supports and provides structural support. Sapwood is the lighter and transports the sap and moisture from roots and stores food. This is the purpose of this sapwood. And cambium is one of the very thin layer between the bark and wood. Like bark will be the outermost part of the stem, right? So between the bark and the wood there will be a thin layer which is known as cambium. And in the bark also you will have inner bark and outer bark. Inner bark pertains to the transport sap from leaves to the growing part of the tree, and the outer bark will be the dense rough layer of protection. What we will be seeing with our naked eye is the outer bark. But after that outer bark you will have different features of the stem. Okay. And coming to the next question, the moisture content in structural timber should be. The moisture content in structural timber should be, like already in the case of other materials like aggregate, cement, concrete, we have seen the limitation in the moisture content. So there will be the if you want to make use of the material as a structural material, then there will be some limitations for the moisture content. The moisture content should not be too high. If the moisture content is too high, the strength has to be compromised. The strength aspects has to be compromised. So in case of structural timber, there is a limitation for the moisture content. The moisture content should be around 10 to 20%. In case of this structural timber, the moisture content should be in between 10 to 20%. So ideally around 12% of the moisture content has to be retained in the timber which you are going to use for this structural purposes. Okay. And coming to the next question, seasoning of timber is required too. Actually, what do you understand by the term seasoning? What is this seasoning? See, from the definition you can understand that seasoning is nothing but a process of removal of the moisture content. A process of removal of the moisture content from the wood. See, seasoning is the process of controlled drying. Like it is a process of controlled drying to remove the sap and reduce the moisture content. But without causing cracks and distortion. For suppose, if I have a piece of wood, or let's say some other material which has the capacity to absorb some water, and after making the material to absorb some water, and if I place it under the sun at high temperatures, what will happen? Like because of the highest temperatures present over there, the moisture will be evaporated, but because as the temperatures are very high, after the evaporation process is done, what will happen is there will be uh, formation of cracks, or the material will be distorted, or the material will be distorted. So that's why the seasoning is the process of controlled drying. It's the process of controlled drying. It's not just the like under some specified temperatures or under some controlled temperatures only we have to do this seasoning process. Then so it is the seasoning is the process of controlled drying to remove sap and reduce moisture without causing cracks and distortion. Cracks and distortion. So that is the purpose of this seasoning. That is the process of seasoning. And the rate of evaporation. The rate of evaporation, that means the rate at which the water, the moisture content will be evaporated from the wood. It will be it will depend on many factors. For suppose it will depend on the kind of wood. Based on the kind of wood, the rate of evaporation will vary, and based on the shape and thickness of the timber, the rate of evaporation will vary, and based on the conditions under which the wood is placed or piled. Under the weather conditions also it will depend, the rate of evaporation will depend, right? So in case of natural seasoning, in the process of natural seasoning, the aim of the natural seasoning is to retain only 10 to 20% of the moisture content. Only 10 to 20% of the moisture content has to be retained. The remaining has to be evaporated. But in case of artificial or accelerated seasoning, only 5% of we will be able to retain 5% of moisture content in case of artificial or accelerated seasoning. But the quality with the artificial seasoning will be an inferior quality when compared to the natural seasoning. So what do you understand by this natural seasoning? Natural seasoning is nothing but you will be racking up or piling up the wood at outside temperatures, like see, natural or air seasoning. That means it will not be directly exposed to sun and water. They will be having some protection from this sun and water, and it will have free circulation of air, and the natural seasoning will be faster if it is immersed in water before drying. Immersed in water before drying. And natural seasoning will usually take 2 to 6 months or more, like depending on the type of wood. That means for suppose hardwood takes more time than softwood. This is the process of natural seasoning. That means the wood will be left at the outside temperatures, like, but it will be protected from sun and water, and air will be allowed to circulate. So it will take much time, like it will take 2 to 6 months of time for the natural seasoning to happen. But in case of artificial or accelerated seasoning, it will be different, but there will be different types, like water seasoning. Water seasoning is immersion in water and air drying. And in case of this artificial seasoning, what will happen is the strength will reduce due to excessive loss of organic material. So in the process of this artificial seasoning, there will be loss of some organic materials also. There will be loss of some organic materials also. That's why the strength reduces here in case of artificial or accelerated seasoning. So these are the different types of artificial seasoning, like kiln drying, boiling, chemical seasoning, electrical or solar seasoning. Electrical or solar seasoning. This is the typical figure where you can see a kiln seasoning of the wood. This is due to this chemical treatment. Okay, so these are the different types of seasoning. So now you will be able to answer the question, like seasoning of timber. It's timber, sorry. Okay, seasoning of timber is required for, like, is it to soften the timber or harden the timber or straighten the timber or remove sap from the timber. So it is the process of removing the sap and moisture content from the timber. That is known as seasoning. That is known as seasoning. Okay. And and these are the like due to attack of dry rods, the timber will become like, what will happen to the timber because of the attack of dry rods, like for suppose when the timber doesn't have proper ventilation or proper circulation of air, what will happen? The moisture content will not be, the moisture content will be high, and it will be decomposed, the timber will be decomposed. So this is one type of attack on the timber, which is known as dry rods, and this will make the timber to become into powder form. This will make the timber to become into powder form. So dry rods make the powdered form of timber. See, the disease of dry rot in timber is caused by, uh, as I said earlier, it is caused by this lack of ventilation. When you have when you don't have proper ventilation for the timber, then you can see a disease of dry rots in timber. You can see a disease of known as dry rots in timber when you have lack of ventilation. See, I have explained the process of seasoning, right? I have given a detailed explanation of the process of seasoning. So I think you will be able to answer this question. Like, the seasoning of timber is done in the following way. How we are doing this drying, like seasoning, whether we are making this drying process, making use of drying, or moist drying, or humidity drying, or hot drying. See, it's not just simply drying or hot drying. We are making the seasoning process under controlled temperatures, and while seasoning, like before seasoning, we are immersing the timber in water. And then we are making it to dry. Actually, the seasoning of timber is done in this humidity drying process. Under this humidity drying process, the seasoning of timber will be done. Okay, the seasoning of timber will be done. See, it is humidity drying. Suppose if you are going for the skill seasoning of timber, the mechanism we are adopting here is humidity drying. For this, in this humidity drying, the relative humidity which we need to maintain is around 40%. You have to maintain a relative humidity of around 40% in case of the skill seasoning of timber. And for the skill seasoning of timber, the number of days required for the kill seasoning of timber is, it is actually around 12 to 20 days are required for seasoning of timber in case of kill seasoning. And plywood is, for suppose you can say it as a byproduct of timber. I'll explain some of the aspects in the lecture. See, these are all the failure modes explained, like what are all the desired mechanical properties. Those are nothing but it should be strong in compression, tension, horizontal shear. It should be checked for all these things. So these are the different modes of failure, like compression, different modes of compression failure. When the compressive load is applied parallel to the grain. These are the grains. The lighter lines you are seeing inside the rectangle or the grains. So when the compressive load is applied parallel to the grains, the failure modes you can see are crushing. This is the crushing failure. This is wedge splitting. This is shearing failure. This is splitting failure. This is crushing and splitting. This is brooming or end rolling. These are the different types of failure modes when the compressive load is applied parallel to the direction of the grains. These are the different failure modes in compression. Okay, and see the adverse effect of the excessive moisture content is it will affect the compressive strength of the wood. It will affect the compressive strength of the wood. See, for suppose uh, this is the graph showing the maximum compressive stress versus the moisture content when you can observe here, when the percentage of moisture content is getting increased, the maximum compressive stress is at lower levels. And these are the tension failure modes, like the tension failure modes when the load is applied parallel to the grain. See here, the tensile force is applied parallel to the grains. So in case of this, you can see splintering tension, combined tension and shear, and this is shear failure, and this is brittle tension. And when the load is applied, like when the tensile load is applied perpendicular to the grains, here the grains are perpendicular to the applied loading. So in that case, you can see tension failure of early wood, shearing along a growth ring, and a tension failure. So these are the different failure modes. And the tensile and compressive strength based on the direction of the growth of the grains. This is the graph showing that vary widely because of anisotropy, moisture content, defect, etc. Like the tensile and compressive strength will depend on all these factors. Like moisture content, defects, anisotropy, etc. Based on all these things, the tensile and compressive strength will differ. So tensile strength is greater than the compressive strength. And when it is like the parallel to the grain is about 20 times, like the tensile strength, the when the grains are parallel, like when the load is applied parallel to the grains, is about 20 times more than the load when it is applied perpendicular to the grains. Okay, see, this is the grain growth in longitudinal direction, tangential direction, and radial direction. So as you can see, in the longitudinal direction, like you can see, the ultimate stresses are more here, the ultimate strength are more, both in tension and compression the ultimate strength are more, but the brittle like the ductility is very less here. You see, coming to plywood is one of the, as I said, it is one of the byproduct. So thin sheets of wood, like thin sheets of wood will be piled together, and they will be stick together. Why the plywood has some advantages over the conventional wood? Because see, plywood will have, for suppose if it has three layers, each layer the grain growth will be in different directions, so that you are making use of the strength, in all the directions. For suppose perpendicular direction, parallel like longitudinal, radial direction, tangential direction. So in every direction grains will be distributed, so that you can make use of the different strength aspects in different direction. That is the main advantage of plywood. Here. Okay, so see, plywood has the advantage of having the same tensile strength in all direction. It will have the same tensile strength in all the direction. The plywood will have the same tensile strength in all the direction, because it will have some layer 1, layer 2, layer 3. For suppose if you have the grains distributed like this, here you will have the grains distributed like this, here you will have the grains distributed in different directions. So, and all of this will be glued together. So these 3 layers will be combined together, like glued together, so that it will have the same tensile strength in all the directions. That is the main advantage of plywood. And plywood can be identified by based on the thickness only. The what to say, the nature of the plywood will depend on the thickness. Nature or the properties of the plywood will depend on the thickness. And I have showed you the structural features of the bark, like structural features of the stem. In that, the outermost portion of the wood is known as, this is the bark, like the outer portion of the wood only we will be able to see with our naked eye, right? So the outermost portion of the wood is known as the bark. The outermost portion of the wood is known as the bark. Like the wood preservative creosote is derived from, actually this is nothing but a type of chemical, which will be used for preserving the wood. For suppose if you apply some coatings of this particular chemical on the wooden, you can preserve the wood for many years, like many years without like you can protect it for many years without any attack from any kind of temperature effects or termites, etc. So the wood preservative creosote oil, it is nothing but a oil which is derived from tar, it will be applied on the wood, so that it will act as a preservative. So these are the set of questions I have compiled based on this week's content. If you have any doubts in the questions which I have framed, you can feel free to ask now. If you have any sort of questions, you can discuss it now. Any questions? Do you have any questions based on this week's content? Okay, if you don't have any questions, I'll stop the session for today, and we'll meet next week for the last and final session, like which is the week 12 content, which is based on the glass. The product is glass, the next week content. Okay, thank you then. We'll meet in the next week.